Hello, everyone. In today's video, we're going to be doing our first case study, which is using all that good programmer knowledge that we've accumulated for the purposes of making this thing go. I'm not 100% sure what this thing is supposed to be. I think it's like a four-seater piece of junk. Don't worry, though. You can get this as well as all the code. I know some of you have been clamoring. Could you give us the code examples you gave us? Don't worry. Well, you'll have access to those and this vehicle. I'd rather not have to copy-paste my code every time because for me, it's more about what you can see and kind of how you think about it rather than taking the actual code itself. But this one I will give folks over on the workshop if you need it. All right, let's take a look at what we got here. So we have ourselves an ugly boxy thing made of aluminum. It's about 1,000 kilograms or so, which is a perfectly good weight. It's got some lights on it. It's got some really, really fun potential to make me absolutely crazy. So I'm going to look forward to that. Obviously, we're going to need some brake lights and all that other good stuff. And the purpose of this video is going to be basically wiring and programming it up. Let's do it. So the first thing I'm going to do is I'm going to float on inside here. And as you can see, I've already got some stuff going on here. I have myself a master switch, which basically runs a solenoid up front. I also have myself a bunch of switches, one for lights, parking brake, and of course, four-wheel drive mode. And I also, of course, have a computer, which I've stabbed in here. Now, if I float up front here, you'll see that the master battery is stored in the nose of this thing. And going forward from there, you can see that I kind of have all my regular electrical logic here. This is basically a solenoid, which allows power to come in and out of the big battery. We have something that steps the power down for low voltage for the purposes of our computer and things like lights and everything like that. And everything is actually pretty well set up here. Like I said, nothing too chaotic or crazy. We're going to try to keep this, like I said, simple so that you can kind of see the magic as it happens. So our wheels, of course, we've got 4 of them. We're going to design this to be pretty conventional. It's going to be rear-wheel drive unless we hit the four-wheel drive switch, in which case it's going to be all-wheel drive. We're going to design it so that when we are not pressing the accelerator, it regenerates electricity. And of course, we're going to make sure we have all-wheel braking as well as a parking brake, plus the lights. Woohoo! That's a lot of work. So the first things first, of course, is that we need to start getting this thing all wired up both electrically as well as logically. Now, the dumb thing we would do here, of course, is we'd float in here, run up to this computer, and basically start assigning values. One of the things you'll see here is I already have one of the holes taken, the channels, I should say. I shouldn't use that term. But the problem with that is I need 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. That's a 10 more connections, 11 more connections, including the seat, which is a lot. That's going to be pretty messy for us. So let's go ahead and be a little bit smarter about it. So what I'm going to do is I'm going to isolate my lights from the rest of my vehicle. So what I'm going to do is design a router that just handles the lights. And again, the reason I'm doing that is just to simplify things a little bit for us later on. You'll see what I mean. So I need to find a spot for this. This seems like a perfectly legitimate spot on the floor in the back seat here. So I'll grab myself a router real quickly here and go ahead and toss that right in here. You can see I have just enough room to get this thing in. If I hold down the X key, is it going to let me get away with it? Shift rather. And I can put it vertically. I can also do this. Haha, look at that. Let's hold down X here. Can I get that between everybody? I can. That's fabulous. And this router basically is going to be responsible for handling all of the lights, like I said, on board this vehicle. It's just going to make it easier. So what I'm going to do is I'm going to go ahead and grab this, run back here, and start slapping in some connections here. You can see they're already kind of integrated directly into things. And this makes it a little bit easier for me to kind of go back and forth as well as plug everybody in here. All right, so I'm going to use the X trick here. If you hold down X, it sticks things into the ground or automatically. We could also put the rear wheels on this, which actually might be something I do. Again, it's a recursive iterative process that you're working through when you're doing R&D here. So I try to keep it simple. Whoa! There we go. Go ahead and grab that one. And hopefully you're not disoriented because I'm starting to get disoriented. Whoa! Let's go float back here. And we'll go toss that in there like that. Fantastic. So now all of our lights in the back are on their own router. You know what? I'm going to do exactly what I said I was going to do. I'm going to go put the back wheels as well on their own connection here. I'll float up here. And again, might as well while it's all back here. And let's see here. Where is that cable? Did I click? Oh, I didn't click it. That would explain it. All right, here. We're going to go use our trick. Plug that back wheel in. Nice. Let's go ahead and grab this back wheel. We're going to go ahead and stick it into the frame here, and we'll stick it in here. Nice. So now the whole back end of this project is basically going to be isolated, logically, I should say, from the front end of the project. And of course, we want to take advantage of that. All right, so next what we're going to do is we're going to go ahead and use how much zipping through here. We're going to plug this into the primary computer. Go ahead and lock that into the floor. There it is. It's just going to go in the back. That just simplifies things a little bit for us. And now the back end is pretty good. We definitely need to think about things electrically for a second here. And again, you can steal this vehicle if you want to play with it yourself later on too. All right, so we've got all sorts of connections here. We're going to have to get all programmed. Oh boy, this is going to be fun. Let's go ahead and get a place to plug that in. You can see I already have my electrical connection for my back wheels here, but we do need an electrical connection for the lights back here. So let's get that all squared away. Let's grab a power converter. And we'll go ahead and toss that over here. Again, it doesn't have to be perfect. It just has to work. I'll go ahead and grab the other one here. This is the low voltage junction. Luckily for me, I have exactly 4 lights back here, so it makes it a little bit easier. Let's go ahead and carefully plug this over into my converter here. Whoa, are you dizzy yet? That's one downside about this game. There we go. Let's go ahead and connect this into the high voltage here. So now we have electrical power back here. Let's go ahead and split, like I said, our different lights into our different lights. There we go. Go get our different lights like that. Go ahead and grab this here. We're going to run to this side. And we're going to connect that last one. So now everybody's powered. So all of our lights are logicked. All of our lights are powered. Our back wheels are powered. And we have a bonus wire. I hate it when this happens. When this happens to you, just delete it. Go ahead and grab the logic one more time. Hold down that X key when you go to click. And that way you can stick it into the wall. I'll stick it down through here and plug it back in. Good. The wire's gone. Good. The wire's gone. We don't have to stress about it. We could hook up the ball hitch back here. We're not going to do that today. I'm not really worried about it. It's just kind of a nice little convenience. All right. Wires are connected. Everything's electrically connected. We're good to go. We need to connect the logic for the front wheels as well. So that's pretty easy. We already have them powered. So we'll go ahead and grab that here. Hold down my X key. Float up to my master computer. Toss that in here real quick. Go ahead and grab this wheel as well. Again, we're going to hold down the X key. Go ahead and jam it into the ground. Click that one right there. So now we have our wheels connected, and now we have 2 more lights, and we are awesome. Like I said, trying to keep this simple today. There we go. And again, nobody will be seated during the watch me plug wires in phase, but it is important you understand where those wires came from. All right, let's get some electrical power on these guys up front. Unfortunately, you're going to see that come through, but that's okay. I believe I have split electrical power here. I do. And let's go ahead and grab electrical power one more time here. Doesn't have to look good. It just has to work. And there we go. So now we have electrical power. And now all we need is electrical power for the router in the back seat. Again, we'll run that wire through here. We'll come down here with it like that. And we'll come right on through and just like that. I think the last thing I need to do is hook up the controller seat up into our controller here. And we did it. All right, let's review. So the first front 2 wheels here are electrically connected up to this big junction here. They are data connected up to the primary computer. Our lights are connected to the low voltage, connected to the primary computer. Our router is connected to everything in the back end of this vehicle. All of our electrical things have been pre-split all in the back, kind of in the trunk here to make things a little bit easier for us. And everything is ready to go. We just have to work out the logic. Oh boy, here we go. So the next phase, what I'm going to do is I'm going to start naming everything. We're going to call this seat, make it nice and simple. We're going to come back here. We'll go ahead and give this a wheel command. We'll do wheel. We'll call this rear left, RL. We'll call this wheel front left, wheel FL. Come around to this side. Come over to this side. We'll call this wheel FR. And of course, this will be wheel RR. Wheel RR. Nice. We've done it. So everything is ready to go. Our programming phase is ready. Let's do it. So what I'm going to do is we're using the mini computer this time, not the big computer. You'll notice when I hit the power switch that these 2 displays come on and say the word standby. The reason they're saying standby, of course, is something I'll do a little later on. I won't do that because this is considered a beginning tutorial. Is kind of walking you through how to make this all look pretty, but I'm not worried about that now. So let's go ahead and crack open our code. I'm going to delete everything. In fact, as a matter of fact, if I press save, my standby will go away. And we're ready to actually do the original coding. So how are we going to set this up? As with everything programming, it's all about doing one thing at a time and basically establishing everything. So what we need to know is getting all of the values. Once we know the values, we're going to save them into memory so that we can use them as often as we need. Once all of our inputs and all of our memory has been assigned, we're then going to apply the actual, they call it the business logic. I like to call that the magic. So let's go ahead and do that now. So I'm going to start by creating some variables here. I'll leave myself a little comment at the top. Control variables. And we're going to go ahead and create different ones. We'll create one for acceleration. That will be a number. We'll create one for steering. That will be a number. Create one for regen. That will be a number. We'll create one for brake. Brah. That will be a number. We'll call one for, let's see, what am I forgetting here? Steering, acceleration, brake, regeneration. Of course, gear. That's going to be important for us, especially if we want to make an automatic. So now we're going to go ahead and get our output variables. These would be our, let's see here, system variables, I'm going to call them. Variables. This is going to be things such as lights. This is going to be things such as four-wheel drive. Oh, not allowed to do that. I'm going to call it AWD. That'll be a number as well. And then I believe our final switch there in the front. So let's go take a look real quickly here. Let's see, all-wheel drive parking brake. That sounds good to me. Parking. Nice. All right. I'm trying to think, are there any other variables we need to know? I mean, we could track if it's like daytime or nighttime or something like that, but that's a lot. All right. So we have all of our control input variables. Let's be a little more specific. Control input variables. These are going to, actually, these are output variables. These are control output variables. These are going to be all the different numbers we're going to be grabbing. We'll just call them control variables. Let's keep it simple. Nice. Okay. Now we need to set all of our variables to a default value. We don't have to do this, but it would be silly not to. Acceleration starts at 0. Steering starts at 0. Regen starts at 0. Brake starts at 0. Gear, we'll start in neutral gear. This is kind of second gear, I guess you want to call it. Let's see here. Lights is going to start at 0. All-wheel drive is going to start at 0. Parking brake is going to start at 0. Now, one of the things we need to do here is we need to make sure that our inputs agree with our initialized values. So if you take a look here, we're using what they call a dash for this. Now, dashes are cool because they're customizable. And again, you can take a look at the code. But just think of this as mini switches that we can alias directly. That makes our life a little bit easier. My dash is called dash. Now, dashboards, each item on there has a unique value, such as this guy for lights is considered channel 2, channel 3, channel 4, channel 8, channel 9, channel 10. That's important for us because we can map those inputs and outputs right away. So what I'm going to do is come down here to where it says lights, and I'm simply going to get the value of that particular channel. Now remember, the lights channel here is channel 2. So I'm going to use the input number command, dash, comma 2. Let's go ahead and get this as well. Input number, dash, comma, this would be 3, I believe. And then finally, let's get the input number, dash, and this would be 4. Now, if I say this, nothing bad happens, but we know that we have variables. Now, this is a good time to test to make sure our logic is good. So what I'm going to do is I'm going to come down here. I'm going to print lights. And the reason I want to do that is if I flip the switch off, resave my program, I can see with the switch off, it prints 0. If I were to come up here, you can see I added a fake space there, save. Flip that switch back up, save, you can see as a value of 1. So that means the input is working correctly, and it is initializing to the value that it actually needs to be. Now my init is done. We don't need to fiddle with this anymore. We just need to fiddle with the actual inputs themselves. Now, if you remember from before, we used the update loop, which is a simple way to do this. We could also use tick. We could even be awful and do interval 10. That'd be interesting, but I don't recommend it. So we need to now get the values from the seat so that we understand exactly what different values we're going to be getting. So let's go ahead and do that now. So I'm going to go ahead and grab up my little reference sheet here to make it a little bit easier. I'll show that up on the thing real quick so you can kind of see. All right. And we can see here that we're in the seat. If 0 is set, we can do backward, forward, left, right, and these are all of our individual channels. Let's do it. Deep breath in, deep breath out. Begin. Excel equals input number, seat. This will be input 1. Steering will be input number, seat. And this will be 2. I got to fix my thing here. Let's see here. Regen is not relevant. Brake is definitely relevant. Equals input number. Seat. I did it again. Let's see here. This will be 3. We probably want to take the absolute value of this, though. And the reason we're taking the absolute value of this is we want to make sure if somebody presses negative brake, it still kicks the brakes. All right. Idiot check. Acceleration, steering, and of course we have brake. Gear, we're not going to attach gear to anything yet. We're just going to leave that here for now. All right. We've got our acceleration. We've got our steering. We've got our braking. Now we're ready to set up our outputs. We should probably make a quick little note here. Get inputs from user chair. Nice. And now we're ready to actually make things happen. Let's see here. What outputs are we going to have to manage? We're going to have to manage the wheels and the lights. So let's go ahead and take care of things first. We'll take care of our control indicators first. Indicator, lights. Now we have a series of 1, 2, 3 lights here. And these lights need to correspond with these switches. These switches should be on in the event that we are using it. They should be off if they're not. So when I hit the lights switch, this light should come on to tell us that the lights are on. Like I said, it's an indicator. Now, just like I was saying before, whenever we're doing anything with dashes, and again, we can get into dashes another day, what you'll notice here is we know what output this is. This one is output dash 8. This would be output dash 9, and this would be output dash 10. Now let's make this really simple. Output number dash, and this would be 8, which would be this one here, would equal lights, because that would be whether or not the lights is on. Flip the switch on, flip the switch off. You can see we have no lights switch whatsoever. So let's go ahead and take a look at what we're doing here. Let's see here, our lights value. Are we getting a lights value? Aha! We didn't get the lights value. Remember how we got the lights value here? We didn't constantly get the lights value. So we're going to have to update those values all the time. Now, very, very slick people would say, wait a minute, can't you just Control X, come down here and go ahead and Control V? Yeah, absolutely. Get inputs from dashboard. Fix my spacing, save. Aha! Now you're saying, is that going to cause a problem? I mean, you theoretically aren't initializing the value anymore. You're actually initializing the value after you've updated. Sometimes it will be a problem. Sometimes it won't be a problem. It will be a problem when you're doing things like joints, and you need to make sure they connect as soon as the software starts. In this case, we can get away with this pretty safely. You can see my little light switch comes on, no problem. Let's go ahead and take care of that for the other ones. Output number, dash 9. This would be, what do we say? This is parking brake. So this would be parking brake. Man, we did this so well. Parking brake. Output number, dash 10. And this would be all-wheel drive. Nice. Let's see if it works. Click, click, click. Something's broken. Of course it's broken. As you probably observe here, the number for four-wheel drive is actually going to be 9. So we have to actually flip those in our code. Let's save and see if that fixes it. All right, let's test it. Yep, yep, yep. Excellent. So we know that our indicator lights are working. You can test them real quick. By the way, it's kind of fun. If you shut the logic off, that shuts off. But if you shut the power off, the light stays on. I don't think about it. This doesn't illuminate anything, so don't worry about it. All right. So now that we have the indicator lights, we're ready for our wheel outputs. So we'll go ahead and do our wheel outputs. And this is going to be where the magic of our vehicle actually kicks in. Okay, so the first wheel output I'm going to do is I'm going to design my acceleration. This is pretty easy to do. So output number, and we're going to do all the wheels on individually for this. Now, the reason for that is if you remember, we're going to be using rear-wheel drive unless we need to use all-wheel drive. Start to see where that gets complicated. So we have to be smart about it. So wheel front left, input number. We're going to have to get the input numbers. Let me get those on the screen for you so you can see exactly what they are. As you can see, our input number, 0 is going to be accelerate. Pull that out of the way. So we're going to say wheel front left, 0, which would be the acceleration channel. And we're going to do accel, but we're going to multiply that by AWD. You're sitting here going, dude, why would you do that? That would mean that if all-wheel drive is turned off, oh, there's no acceleration. Exactly. All right, let's go ahead and get a wheel front right. Now we have a problem, a really big problem, and let's go demonstrate that for you. All right, let's go ahead and climb my front seat here. I'm going to flip on my all-wheel drive and press forward. Now you'll notice here that our little craft, as I press the W key, we're not really going anywhere right now. Now you're sitting here going, why are we not going anywhere? According to this, everything is all squared away. I've got all-wheel drive clicked on. Isn't this working? Are you getting the correct channel? If you remember, channel 4 is the all-wheel drive channel, and we're getting channel 3. All right, so now, unfortunately, you can see our switches got switched again. Isn't programming awesome? All right, now we're good. Whoa! As you can see, when I press the accelerator, we go in a power circle. The reason we're going in a power circle here is because one wheel is facing the opposite direction of the other wheel. So if we want to fix that, what we're going to have to do here is we're going to have to actually adjust our logic a little bit here. We're going to have to say, on the right side, negative acceleration. Let's try it. Hey, look at that. And you can see we're now going forward. Now, the joke here is if I shut off all-wheel drive, I've lost control. I have no control. As a matter of fact, I have no brakes either. All right, output number, wheel. In this case, I can do wheel asterisk. Actually, we can't. We'd have to do rear left. 0, accel. We don't have to worry about all-wheel drive. Output number, wheel, rear right. 0, accel. And the reason we don't have to worry about all-wheel drive here is because the rear wheels always are running. So what's the point of multiplying them by that variable? Uh-oh, we're doing a circle again. No problem. Let's just make it negative. Hey, look at that. So now we're rear-wheel drive mode. If I flip the all-wheel drive switch, whoa! This thing's got quite a bit of a get and go. Let's go ahead and tap the four-wheel drive there. Whoa, look at that, man. This thing's got places to be. I just lit up those back tires something hard. Wow, this thing knows how to move. Awesome. Everything's going very smoothly for us. All right, so the wheel outputs are half done. These are going to be for acceleration. So now what we're going to do is set up the brakes. Brakes. Okay, now this is pretty easy because I can simply say wheel asterisk, comma, and one of the things we can do here is we can go ahead and design this so that the brake input, which is brake input 3, equals brake. Now, the cool thing is, because all of our wheels were named the same way, we can use the wild card. Let's test it. Forward, brake. That's awesome. Now, you're probably sitting here going, what about the parking brake? Isn't that like something special? Don't we have to like do something for that? Absolutely. As a matter of fact, one of the things we can do here is we can add the value of parking brake right here. And the reason we can add that value in there is because it's a value of 1. So, oh, brakes. Oh, we're not moving. Now, the cool thing here is that basically gives us 2x brake. And it gives you an idea of how aggressive that is. So if I hit space bar, we stop. If I hit the parking brake, go. Oh, that brake is too good for us. Yes, you're correct. We are an all-wheel drive parking brake, which is actually a little different. So if we hit the brake or we press the parking brake, we get brakes. Now, some of you get all panicky on me and say, wait a minute, isn't this going to be a value greater than 2 or 1? Isn't that going to cause issues? No, it's just going to round down and clamp the value. If this bothers you, we could actually do this. And we're basically saying don't exceed a value of 1. So the advantage to that, of course, is, like I said, it's whatever value is bigger. Actually, we'd have to do a max min. So I'm not even going to do this. Disregard the thing I just did. I don't want to do it because it's just going to complicate things. There we go. We got some acceleration. Parking brake works perfectly. Now, if we were smart, we'd actually design it so that the brakes and the gas cannot be used at the same time. That's just smart. All right, now we have to deal with steering. This should be pretty easy. Let's see here, steering. Output number. We're going to deal with the front wheels. Wheel, front, left first. Our steering input is 1. Now, remember, we have to reverse the steering here. Otherwise, it's going to make you crazy. And again, we use steer. Let's go ahead and take a look at that front left wheel. Nice. Let's go ahead and set up the front right wheel. Copy paste is your friend. Looks like I did not need to reverse the steering. In that case, I'm going to make my life easier. Go here. We'll use the wild card one more time. We'll go with F asterisk. Why not, right? Let's see our quote, and we're going to go ahead and do set steer. So that's going to be that steer. Let's test that. Oh, it's so good. Look at this. Oh! Look at those back wheels. Brakes. Isn't that awesome? All right, cool. We're doing great so far. So we have a working car now. So if I hit the accelerator, we're going. Obviously, we're in rear-wheel drive mode here. Whoa! This is rear-wheel driving real hard for me. All right, let's go ahead and throw it in all-wheel drive mode. Go! Gosh, this thing accelerates quick. Whoa, it's got a little bit of drift to it. That's aerodynamics. Brakes. Whoa. That thing's terrifying. Let's go ahead and hit the thing. All right, so there's a couple more things I'd like to do. Of course, one of the things I'd like to do is I'd like to get the lights set up. My steering is pretty good. Now, one of the things I mentioned earlier in this film was the fact, or video, I should say, this ain't no film, is to go ahead and set up regeneration if we don't hit the accelerator. That's easy. So what we're going to do is we're going to set up the regen to only kick in if we are not accelerating. So I'm going to create a simple if statement. We haven't done if statements yet, but for this one, I'm just going to be good. Regen. So we're going to say if, let's see, not excel, which simply says if we're not hitting the accelerator, output number, wheel, we'll use asterisk here. Remember, regen is going to be hole number 2, or I keep saying that, channel number 2, and we're going to go ahead and call this value of 1. Else, and we're going to have to make sure we undo what we just did here. Wheel asterisk 2, 0. Simply means do not hit regen if we're not touching the accelerator. Let's try it. So I hit the accelerator. Again, a little bit of slip there. Getting up to speed. Now watch this. If I let go of the power, do you see how this whole thing slams forward? I am regenerating electricity. And as a matter of fact, I can demonstrate that very smoothly for you. Watch this. Let's get out of my seat. Let's go up to the battery up here. We'll go ahead and recharge that battery real quick. Float back to my chair real fast. There we go. Watch this. So you can see here we are draining that battery. Now when I let go of the accelerator, do you see how it's actually reduces its discharge rate quite impressively? Or we could say, let me just check something here. If excel equals 0, actually equals 0. Let me just see if that works a little better. Go ahead, full power, full power, full power, full power. I'm going to get this thing moving. Release the accelerator. Yeah, it was working exactly the same. And you can see that that's killing us pretty effectively there. Doesn't generate a lot of energy, but it definitely helps reduce it. Remember that we're running the computer as well, so that's going to be impacting us. We'd have to basically drive up the top of one of those hills or something like that. Woohoo! Yeah! Oh man, is this thing a drift king? Gosh, this thing drifts hard. Yeah, look at this. This is why I don't like rear-wheel drive cars. Cool, parking brake. Our logic is good. I actually like the other one better. That was cleaner the way we did it. If not acceleration, simply meaning is acceleration equals 0. All right, we're good to go. So we have brakes, we have steering, we have regeneration, we have acceleration, throttle. Our wheels are looking great. Let's get our lights going. Now we have a lot of lights on this thing. And of course we have the headlights up front, and of course we have the tail lights out back. A couple things I want to do with the headlights and the tail lights. Obviously with my tail lights, when I hit the brakes, I want the red lights to come on. So we're going to have to name these. We'll call these lights, brake 2. Actually, that's not how you spell brake. We'll come over here and we'll say lights, brake 1. And of course, we want to do reverse lights as well. Lights, rev 1. Of course, I could do rev left and rev right, which is actually smart, but that's okay. Rev 2. And then, of course, we'll do headlight 1, headlight 2. Headlight 1. Actually, this makes no sense. Headlight 1. This would actually be headlight 2, because we're on the other side of the car now. This would be headlight 1. Excellent. So we have all of our headlights and we have all of our brake lights. So we have to be smart enough now to turn these lights on anytime our car is not accelerating. That's easy, because remember how we set up that regen? All we have to do now is output the number to the brake lights. So lights, brake, asterisk. It's going to be input 0, and it's going to be a 1. Obviously, if we're not pressing the brakes, we'd go ahead and do this one as a 0. So what you'll notice here is both of my brake lights came on. That makes perfect sense because I am on regen mode because I'm not hitting the accelerator. Let's go ahead and make both of these lights nice and red, and we really don't need an angle that wide. I'll do like 20. Again, these don't have to be super duper powerful. All right, so let's go jump back inside real quickly here and climb inside. Let's look out back, hit the accelerator, and you can see the lights, brake lights come off. Obviously, my parking brake's on. All right, full power, release the accelerator. And you can see my brake lights come on just like that. Isn't that awesome? That is awesome. If I stand on the brakes, obviously the lights are going to come on. But as long as regen is going, you'll see that it does a nice job there. Excellent. Let's design our reverse lights. Now, the reverse lights are a little bit harder here because those lights are only supposed to come on in the event that naturally our vehicle is going to be going backwards. How do we know if the vehicle is traveling backwards? Now, that's a bit of a puzzle. And now the problem is we don't know how fast our vehicle is going. So we don't know if it's going backwards. We only know if you're holding the basically the accelerator key backwards. We can work with that. Let's do it. So I'm going to say if Excel is less than 0, that simply means we're holding the backwards number. And we'll go ahead and turn on our reverse lights. Now, you're probably sitting here going, well, if I just stand on the reverse, even though I'm going forward, my reverse lights will come on. Yeah, that's correct. All right, we call it lights rev, I believe. We'll use our wild card again. Otherwise, we'll say else, and we'll say shut those lights off. Obviously, we don't need them to be running right now. Whoops. All right, let's shut those lights off. 0. Let's try it. Burp, burp, burp. The brake light's go on. Burp, 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 burp. Sorry, we don't get actual sound effects in here. Look at that. Now we got brake lights. Woo, 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 woo. I'm sorry, the sound effects in this game are amazing, except when they're not. Isn't that awesome? All right, our last puzzle, of course, are the headlights. And now this, you could probably do without me. This, of course, would be this. We need to handle our brake lights here. This would be reverse lights. And, of course, what we want to do now is we want to go ahead and get our headlights. Now, this is easy because all we have to do is output number. Remember, we called them, what do we call them? A light's head or something like that? That would have been smart. Headlight. See, we were smart. Headlight asterisk 0, 1, 0. And this would be, what do we call it? Headlights? What do we call it? What do we call it? Lights. Got it. All right, save. Let's do it. Go ahead and flick on the headlights. Hey, look at that. Shut off the headlights. Look at that. Of course, you can't see it. Time add 5. Rip. Go ahead and shut my light off. Turn my light on. And would you look at that? Not only do we have headlights, but we also have brake lights. So if I were to hit the background, you have my reverse lights. Hit forward, you can see this thing accelerates. If I were to let go, you can see the brake lights come on automatically. I can stop this thing just like that. Now, a smart person would probably say you can't see anything in this car without a dome light. Yeah, whatever. Well, if you need a dome light, you've got a flashlight if you need one, but that's perfectly fine. All right, let's go ahead and bring the time of day back to, that looks pretty good there. Got a nice little kind of a light coming in. So as you can see, we were able to design this thing pretty quickly, and we were able to wire it up very quickly, but it is incredibly, incredibly, incredibly flexible. If we wanted to redesign this vehicle so that, for example, it has more lights on it, which is totally acceptable, we could. And all we would have to do is change the name of our alias there. This thing's a lot more polite in four-wheel drive mode. Even though, yeah, I know it's technically all-wheel drive. Oh, well, relax. Let's see how bad. Well, unfortunately, I don't have a recovery button in the event that I flip upside down. But fortunately, the game has that. And you can see I've got my little vehicle here. So as you can see, a basic programming can take you so far so quickly and give you a lot of that flexibility that you get trying to get from other systems without really having to stress that much about it. And again, we have a pretty fast vehicle here, but we could actually make it faster if you wanted. Now let's make it a little bit faster. Gear 1. Watch this. Oh, there we go. Now we're moving. Yeah, we're probably doing about, let's call it 70, 80 kph right now. We're moving pretty quick. And again, you can see just how easy it is to do programmatically. I just love the regenerative brakes. It's so good. And you can slam on the regular brakes. This thing is so cool. So what I will do is I will pop this up in the workshop, and I'll post a little link to it in the comments if you want to fiddle with it yourself. I'm also going to add a little display in here to make your life a little bit easier to kind of identify like what your speed is and what your battery life is, so you can start getting prepared for that. Our series, of course, will continue, assuming this is relatively successful. We'll take a look at conditionals, we'll take a look at iteration and functions, which are really, really important. Enjoy.